Hi guys, welcome back to the shop. Hey, today I've got kind of the last 2 or 3 videos have been some little small operations that we need to do. That's going to continue for a while because we just have several smaller little jobs that do need to be done. Today I'm going to try to weld up those cases, the magnesium cases, and I've got to say that I had a friend that follows my channel, and he sent me a magnesium case to practice on. It was pretty beat up, had a big chunk out of it, and I'll try to get some pictures of it. I've got some stills, but I don't have any video, I don't believe, of that case before and after. And I'd watched some YouTube videos on other people welding them, and it just sounded like it was going to be more difficult than it turned out to be. However, that being said, the case that I did wasn't too bad. It may be a different compound than the one I'm going to do, so the jury is still out. But I'm going to go over some stuff that I've learned about it, and actually that case, I was able to get a very good job done on that, and he didn't expect this thing back, but I'm sending it back to him because I think it's repaired pretty nicely. So we're going to send it back, and he can finish cleaning it up and everything, and maybe put a little bit of filler in a place or two and paint it up. He didn't expect to get it back, but he's getting it back because he loaned it to me to do some training. Anyhow, what I did find out with this, with magnesium, is basically you're going to weld it like aluminum, but a couple of things that are different. You're going to have to get used to this green kind of tinge while you're welding it. Instead of this bright light, you're going to get a green light, and it's kind of disturbing, but it melts at a lower temperature, so you've really got to watch it. It does start to wet just like aluminum does, if you've ever done that, and you've got to be really right on top of it or it'll drop out on you. That's the only thing. You just got to creep up on the temperature, and it seems like you start adding rod a little bit earlier than you do aluminum, and primarily that's because you're trying to cool it down by getting the rod in there so it doesn't drop out on you. Now, this is cast magnesium, and actually a lot of cast aluminum is very similar that I've done. But the one thing that you've got to do is you've got to use magnesium rod, and it's very expensive. I bought a pound of it, cost me $130 some, and I used one whole stick doing this gentleman's case. It had about a quarter size hole knocked in it, and I did use about almost a whole stick on that. So on this one here, started out, we just had this chunk out of the Kickstarter area, seal area. And then as I got further into it, I found that somebody had JB welded 2 other areas right here by the Kickstarter. So those have got to be welded up, plus this piece here. And on this one, I'm going to first turn out a piece of stainless steel to just put in here so that I don't have so much work afterwards trying to clean that up so a seal will go back in it and seal. So let me get you overhead. We'll look at a little bit more of what I need to do and discuss some of the properties of magnesium. And we're also going to start on the chain tensioner for the RM Suzuki. Okay, this is the case we're going to repair. And some of the stuff that I learned off of YouTube was, in one of the best videos I ran into was weld.com featuring Wyatt Swaim. And Wyatt tragically died about a year ago in a car wreck. I had talked to him several times on the phone, and he was a very knowledgeable person. He did a lot of welding for the Indianapolis 500. He was early on engaged with aerospace contractors quite a bit, and he really knew his stuff around welding aluminum and exotic metals. I don't know whether he would have remembered me again, but I had a long conversation with him, and he was very willing to provide information, and I did buy a couple of welders from him too. But it's just a tragedy that we lost him. So this is the case, and after I dug out some JB Weld, I found this hole, this one up here, and this is a crack right here that's still got the material in it. And some of the things that Wyatt explained in his video, you can just look that up, weld.com. It's just look up welding magnesium. He's one of the first ones that'll pop up. But he talked about how you had to use a special rod, how you've really got to be clean with everything, and you've really got to watch your temperature. And those are all things I found out after watching his video and trying to attempt it myself first. Now, that being said, how do you tell whether you've got magnesium? This one, of course, says magnesium, but if you didn't have that, a way to do it is just with plain household vinegar. This is white vinegar. You see the foaming? Aluminum will not do that. So the foaming is a telltale sign of magnesium. In this case, like I said, the case itself says it is, but there are some out there that don't. And if somebody just happened to bring you something and you thought it was aluminum and you use aluminum weld or rod on it, it's not going to work. It may look like it's a good job, but as soon as you put a little pressure to it, it's going to fall apart. You've got to use magnesium rod. And in this case, I'm using, let me grab that rod real quick. I believe it's 92. Yeah. It's ERAZ92A. And Wyatt said that that was a very good all-purpose rod for magnesium. There's some that, if you've got different compounds or whatever, there's some that might work better. He also said that if you could weld on both sides of your weld, it will prevent warping. So that's what we're going to do, and that's what I did on this gentleman that sent me the case to practice on. We'll weld in here first, and then we'll come back out here and we'll weld the outside. And then we'll go ahead and see if we can fix this portion right here. First thing I'm going to do, go over to the lathe and turn out a little piece of stainless steel, just that'll fit in here. And hopefully the magnesium will not stick to it. We'll be able to finish this up, and we won't have to worry about digging a bunch of it out of the seal area here. One other thing I want to do is the magnesium. This is some that I ground off of the other case that I practiced on. Magnesium is pyrophoric, I think is how you say it. Otherwise it burns. And the one thing, when you're doing it to a case, if you're TIG welding, and you're TIG welding with the proper setup, you don't have to worry about it, because you're engulfing that weld area in an inert gas. In this case, I'm using argon, so it won't be able to burn anyway. And it really is not that combustible in this form. Now, these are some shavings that came off of it. In this form, it's very pyrophobic. You can see the sparks. All right, let's try it again. We had some sparklers the first time. There we go. A little better view of it. Anyway, it's not as combustible as one would think, but it will burn, and it burns easily easier in these shavings, or in like if you're sanding and creating a powder. And of course, you don't want to breathe this stuff. So let's get over here. I'm gonna prepare the piece of stainless to go in here. Then I'm going to go over and I'm going to reshoot this with a bead blaster, and then I'm going to clean it with some acetone. All right, we'll just trim down a small piece here to stick in there. Got about 188 thousandths to take off. Well, that was pleasant. Okay, we got about 6-7 thousandths. We finish that up. It's hanging on. Okay, we've been back through the bead blaster. This corrodes really fast, so you need to, if you bead blasted it yesterday, you need to do it again today, because it just really corrodes quickly. All right. So we'll let that dry a little bit. I know you can't see much here, but I'm going to do like I did with the swing arm. I'm going to get in there and just kind of hunt around for impurities, try to clean it the best I can. But everybody that I've watched videos on say it's very dirty material. Plus, you've got to remember that oil has been in here. Even though we've cleaned it, it's probably not going to be the best that it can be. So the first thing we'll do is just go in and try to clean up some stuff, and then and it'll be heating it up too. Okay, you can see the black stuff. I'm almost certain that's oil more than anything that's bringing it up. So I'm going to go in there and with some acetone and clean that up again. And then get in there with a stainless steel brush and again clean it. Everybody that I've watched videos on are saying how you've got to be clean. Okay, you can kind of see the progress out here. It's not a pretty weld, and still a lot of impurities coming up, but I think we've got it sealed up. So we'll let this cool, and then we'll looks like maybe right there I need to get in there and do that a little bit. All right, that looks better. So let me work on it a little more. I may not be able to get this in there since it's so hot. Nope, it did go in. Okay, so it's good. So that's hopefully going to keep us from having to clean up so much of the inside. Going in here and cleaning this up a little bit. It's really got to be clean. Okay, you can see the weld we got around the kickstarter there. I'm going to see now if this will come out of there. And it's moving. Just going to have to work at it a little. Okay, got our stainless steel out of there. So we'll go ahead and we'll trim this up. And I've got still got to work on this. I've got this kind of cleaned up on the inside, so I'm going to go ahead and start in there. Okay, so we've got it pretty well covered on the inside. So we'll be grinding out what we can. It's got to be, most of this has got to go away because the clutch is pretty close in here. But I think we can get her done. And if we've got any porosity or anything, then we can get back in there and take care of that. And of course, the outside, stuff just does not weld very nice, not pretty. So you kind of got to put it on pretty thick and then grind it off. Okay, guys, I'm just taking a little of this JB Weld and kind of all the really beat up places, trying to fill those up. This was really beat up bad here. I've got another case and it's even worse. So I'll probably be doing that to this one before long, but this one doesn't, it's not supposed to have any holes, but now this one wasn't either. And this was supposed to be the only repair area, but I ended up with all this stuff messed up here in the kickstart area. And I think there was some problems with the kickstarters came loose and stuff and did a lot of that damage there. But anyway, I'm putting some JB Weld on a lot of these places. I've got some over here because there was a lot of pock marks there too, even though after I welded. So it's just part of it. If you know, I suppose you could use some body putty too, but I've got the JB Weld. I think it might be a little more durable. So that's what I'm doing anywhere where there's some pretty good little chips. And I can see here where I'm going to have to add some more to this area. But you need to go in there and sand and make sure first. But anyhow, I'm going to do this, and then we're going to work on that chain tensioner. Okay guys, shouldn't be a whole lot to this. I've got a piece of 1/8 inch flat stock here. I'm just going to draw these out on. I've already put some machinist dicom on it, and I'll just pretty much trace everything. Not a big deal. You know, I say it's not a big deal, but yeah, it'll probably be a big deal. But it shouldn't be. And I'll just do the same with this one. And we'll be cutting this out of a piece of round stock. And we'll just use a die to thread the end of it here. It's 10 millimeter 125. So we'll do that. I've got a couple new bolts here, and the 2 new spacers, and the rubber rollers. And we'll reuse the spring. I'll clean that up a little bit. So there's not a lot to it. It's just we got to cut this out, drill some holes, and this is probably going to take longer than this will, because I've got to start with a piece of material this big. Okay, we're making this in Imperial. I'm just getting close. So my hole is going to be 15-30 seconds. Primarily because it's pretty darn close to what I'm looking for. Okay, our length is right there. We've got to take off, what was it, about 30 thousandths, I think, off of this. Both the ID and the OD were pretty close to what we need. have to get some oil. It's just about empty. Okay, we're going to start the bolt. So this will be this end of it, and so we're at about 11/14. So somewhere out here. Okay, so it should be to there for the beginning of the washer. And we don't have a lot to take off for that, about 20 thousandths. This had already been worked on a little bit. So let me see where we're at. I'll take a little cut there and see where we're at. I'm using 1144 stress proof on this. It machines very nicely, and I don't have to do any welding to it, so it should be okay for this. I think I got my eye on that scratch. We'll take a look though. Yeah, just almost there. I lost it again. Nope, I just cut it out. It just hit it. All right, so that's good. That's where the washer's going to be then, or the one end of it, this one here. So we'll now cut this down to this, which we just made the interior of the this right here, and actually that fits in there pretty nice. But it's oblong. It's worn out on one side, so we're making this fit this piece right here. So we've got quite a ways to go, and because looks like we've got to get down to about 468 or something like that. So let me get with that. Trying to remember, isn't the 1144, is there another term for that, like 12L14 or something like that? I'm sure some of the machinist guys out there will know. Sure does machine nice though. Okay, I think we're just about there. I'm going to put a little grease groove just like on the original here in the middle. pretty close. I think I need to go a little bit deeper. Another thing we need to do is put a screw hole in the end of this. That's a little snug. Yeah, better that way. Looks like I need to. Let's see, that's not a, I may just have to run the drill bit through it again. But this is about where we want it. So next thing I need to do is put a 6mm tapped hole in the bottom, 6mm one. We'll start our little bit there. Okay, this here's our threaded part. So that's about how deep I'm going to go. And I'm using a number 8, closest I've got to a 5mm for this sort of thing. Should work just fine. Okay, this is going to slip. I'm just going to start it on here. Oh, that's a pretty dull one. I've got a bottom tap and this one. Let me see if I can find another starter tap. Okay, so we've got it threaded. There's our grease groove. And we've got a bolt that goes in here, and that just gives this a little bit of room to move, not much. Not sure what it is, maybe 7 or 8 thousandths. So now we're going to turn it around and work on the other side. We've got to get it down to, actually I'm probably going to have to cut it off first. Then we've got to get it down to 10mm, I think. Gotta get some threads on this. Keeping a little pressure on it here as we start it. It's turning. I was afraid of that. It's pretty small. Might pull it off. Still doing it. All right, see if I can find a nut. All right, there we go. Okay, we've got the little 6mm bolt goes in here, and with a washer and lock nut. And over here we're going to have a flat washer and lock washer and a nut. And that goes through the swing arm right here. And this is going to hold the bracket for the chain tensioner. I think it's easier to drill all these holes before I cut these out while it's still in a nice square format. This is the spring catch. Got to weld that on right next to the piece that we just put on. Okay guys, here we go. Here's our new one. I don't think I need to add the stiffener to this. This is thicker. This one was made out of sheet metal, basically. And I used the same as I used on the other side. These are almost the same thicknesses. So I'll plate all this when I get ready to do plating. Got the new rollers in there, and here's the new piece that we made. And I believe that's going to go that way. And then we get this over here. And we'll just move this stuff out of the way. Okay, this goes this way, and then that spring goes underneath that one. And then we've got our washer and nut combo over here. So I think it's going to work. Let's see here. Okay. We'll just pack that full of grease before we put it together for the final time. So I think that's going to work. This one just had so much wear in it. You can see where it had a lot of, where the chain rubbed here and here. And they actually patched it here, put some stiffening in it, because it looks like it just about wore through back here. And this piece here, you can see that there's pretty good ribs on this side. And then when you turn it to the other side, it's almost very little step left to it. So I think that's really going to tighten everything up. And it's made out of a heavier material. Should last better. I just put that on by hand. You ever do that? Put something on by hand and then all of a sudden you go to take it off and it's like it's on there wrench tight. Okay, there's our new one. Okay guys, there you have it. If you got our new chain tensioner built up. We got our case welded up. I've still got to get in here and finish smoothing all this out. I've got a few more little nicks and stuff I've got to treat too. It's there's quite a few on there. It was pretty well beat up, but at least we shouldn't have any problem with you know, oil leaking or anything like that. So that was new to me. I'd never done the magnesium welding, and when I started to weld this, I forgot to take the sander, or actually the grinder, and grind it the first time. And once I did that, it welded so much better. And I knew that. That's what I did on the other one. I was trying to do everything step by step, and I forgot to do that. And that was part of the reason I was having so much splatter when I first started welding it, because it just wasn't clean. Another thing that Wyatt told me is that the corrosion that forms on the outside of magnesium is harder and has a higher temperature or melt point than the magnesium itself. So that's part of the process. You've got to, not only do you need to bead blast it, but you need to go in there and just really get that surface corrosion off, you know, because otherwise you've got to heat up the corrosion hotter than what it would take to weld the magnesium itself. And once you start doing that, then you're just going to drop the bottom out of it, because it goes through, hits the magnesium, and pooh. So that was a mistake that I made. The still photos that I did for the case that my friend sent in for me just to play with, he didn't expect to get it back. Anyhow, that one I went through every step, but I guess getting ready, trying to get it filmed and all that, I forgot to do that. But once I did it, everything worked great. So it's just if you ever welded aluminum, it's just a little bit more sensitive than aluminum, and it's a lot dirtier. So you're just not gonna have a pretty weld like you're going to on aluminum. Anyhow, hey, we got a couple other things done, and we got more to do. So stay tuned, and I appreciate you going on the ride. See you next video.